In this video, we'll talk about functions in Kotlin. And I'm actually going to break this up into two videos, two lectures, just because there is the very basics of functions, which I'm going to cover in this video, that I think you will pick up immediately. Very, very simple. The second lecture, we'll get into some more advanced concepts and things that might be new to you. What it is, I'm going to stick with what on the previous lecture, we talked about if statements. And so I'll kind of stick with that, but we'll use functions. So to create a function, as we've already seen in the main, fun main, I can create my own function by just doing fun, and then I give it a name. We'll call it fun bigger number, and then I enter the name of my parameters. So in this case, we're going to see if one number is bigger than the other. I'll just call it num1, which is an int. num2, which is an int. And we'll do colon int. So what do we got up here? This is the basic syntax that you'll see. And in this case, fun says it's going to be a function. The name of the function is bigger number. This one takes two parameters. The variable name is num1 and num2. The data type in both cases is integer. And then I do that's all in parentheses. Then after the parentheses, colon, and then the return type. In this case, I'm going to return an integer. If you don't return anything, you can leave it blank. One thing I want to call out now, just in case you ever see it, because you've made a mistake in your code. If you return blank, like in other languages, it would be a return type of void. In Kotlin, the return is never void. If you don't return anything, the function will automatically return a data type called unit. Unit is a data type, and the only thing that unit ever has is the value unit. That's it. So it's for internal, for the way Kotlin works and the way they do things with function, they needed to return something. Didn't want it to be a void, so they've created this new data type called unit that has no value other than to be what is returned from a function that returns nothing. But sometimes if you made a mistake in your code, like you call a function or something and you didn't call the function right, or you didn't return anything, or you tried to assign the return of a function to a variable but you didn't actually return anything, you'll see that your variable is now unit. That's what it means. All right, so enough on that. So let's write some code in here. So we're going to do the same code as we did before. So we'll say if num1 is greater than num2. What I want to do, I want to return num1. So return the bigger number, else return num2. Very simple. Basic idea of a function. So now I can come down into name, or into my main function. And let's do val big number is equal to bigger number. We'll do 9, 123. And let's do print line. Just so that we can see it all work. Run our code, 123. So again, function, big number, two variables, returns an int. Here's my code. I do have to have a return statements, right? If I didn't have return statement somewhere and I tried to run it, we're going to get an error because I didn't return a value. So somewhere all paths have to return. And I can assign, right? So I can assign the response to a variable. In this case, I did to big number. Big number is an immutable integer. This returns an integer, so this is inferred. The data type was inferred as integer, and then I print it out. Pretty straightforward. Works exactly like every other language you've ever used, most likely. So with that said, let's talk about a few things that are maybe a little bit different than what you've used. So let's go through first, see what order I want to cover this in. Let's do this first. Named parameters. So you can go up here, in this case num1 and num2, this is the name of the variable. When I call this function, actually, you know what, let's comment out the old ones so you see. There's going to be several different styles that I want to demonstrate. So I want to leave these up so you can see them. So you can actually, to make your code a little more readable, you can say num1 equals 9, num2 equals 1, 2, 3. So it's called name parameters. It is something that, you know, sort of started to come in fashion a little bit in the late 80s and early 90s. A language, Ada, started kind of pushing for it. Ada was heavily used in the government sector. But back then, it felt very wordy, and compiler or IDEs weren't nearly as nice as they are today. So it required a lot of typing and mistyping with name parameters. So it kind of fell out of fashion. But as software engineering as a craft has matured over time, as our editors and IDEs have gotten better, named parameters have seen a resurgence. They were certainly a big part of Objective-C, which is what you used to use to write iOS apps in. Then Swift and Kotlin now both make heavy use of named parameters. For Kotlin, what you will mostly see is people won't explicitly put these in, but the editor will sort of put them in. And what I mean by that is if I called this function bigger number, 9, 1, 2, 3, the editor won't automatically add in num1 equals num2 equals, except for it will show it. And so what I mean by that is in the source code, it's still 9, 1, 2, 3. But in the IDE, it's actually going to show in, I think it's like a real light gray font. It'll actually show num1 equals 9, num2 equals 1, 2, 3. You'll see that when we switch over to Android Studio. But you see it in Android Studio, and you also see it if you download, oh shoot, what's the name of it? JetBrains, whatever it was. The IDE that, yeah, JetBrains, that Android Studio is built on. But in this case, I'm going to have to type them out. So name parameters at first, you know, I've had a lot of students who they first see this, they, oh, you know, why would you need that? That's all that extra typing, and anybody can see that clearly it's num1, num2. It doesn't add anything. Okay, in this example, because I'm using this really silly little function that would never probably exist in the real world, and I have these terrible variable names, num1, num2, yes, adding num1 equals 9, num2 equals 1, 2, 3 doesn't make your code more readable. But if you think name parameters aren't great, that just means you haven't had to work on anything large and complex. Because let me tell you, name parameters are fantastic. If you're working on, especially, you know, when you're working on large projects, working with a lot of code that other people wrote, or code that you wrote 6 months or a year or 5 years ago, having name parameters makes everything easier to understand. They are the greatest thing ever. And what's nice about the way JetBrains is doing it is you get to see them in your code, but they actually are never really part of your code. It's just something the editor sticks in there, which is pretty nice. Most other editors actually will automatically fill these in for you. So you can kind of debate which is better. Honestly, at the end of the day, it all compiles down the same and it doesn't matter. So anyway, if I run this code, it'll be the exact same thing. 1, 2, 3. But of course, there's more than that. So let's do val big number equals bigger number 9, num2 equals 1, 2, 3. This runs just fine too. You don't have to name all of your parameters. You don't see people doing something like this a lot. Most of the time, if I see somebody doing this, it will be because they're an Objective-C or Swift developer. They work on iOS and they've come over and they're doing some work in Android. In Objective-C, the common thing was to not name your first parameter but name all the rest. That was just kind of the practice. That was part of the language. And that has a lot of Objective-C developers turned into Swift developers, and you see that continue on. And so it's a very normal thing. In Kotlin, you don't see it quite as much. And I won't get into, actually I'm going to stop there because I could talk about this for about 15 minutes on how it's different and why. But know it exists. You don't have to name all the parameters. And just to get even funnier, I don't have to do them in the same order. So if I run this, I'm still going to see 1, 2, 3. But if I went up here into my code, just to kind of prove it, here, let's print. I'll print num1. Right, so we're going to print num1 when we run this. And you'll see that num1 is 9. Oh, I should have done print line to make it easier to read, right? So what's happened here is I've switched the order, and the compiler, because I added the name of the parameters, the compiler knew exactly what I meant. I mean, for this to be num1, this is num2, so this is 9, this is 1, 2, 3. Not something you're going to do very often, but it happens. Where, you know, why is it this? Why does it work this way? Well, partly just because it can, but also this is handy. One of the good arguments for always naming your parameters, besides being easy to read, but explicitly naming them, not letting the IDE just kind of shadow put it in, but to really put it in there, is that if you refactor these functions later, and for whatever reason you think that a different order makes more sense, you can change the order up, but now all your old code's still fine. Right? So if later on I decide I really want num2 first, I can switch it here, but it actually won't matter. All the old code that's written in your application will stay the same. Not a good reason, but it's one of the reasons why it works that way. So, some of the other fun stuff that we can do that you may not have seen before. I'm going to shorten this up a little bit since we don't need that anymore. Well, I can add a default value. So in this case, I've said num1 is an int, and num2 is an int, and it equals 100. Actually, let's make it 1,000. Oh, it's always bigger. So we'll go down here to, let's just go to the first one. So if I run this right now, it's going to run exactly the same, because I assigned num1 is 9, num2 is 123. We had a default value, but we've overridden the default value when I called the function. But I can come down here, and since I have a default, I can now do something like val big number equals, not bugger, but bigger number. And I could just say, let's do 100. Let's do 101. I run this, and we're going to see 1,000. So what's happened here is I didn't give the name of the parameter. Sorry, up here. I didn't give the name of the parameter, so it automatically added the first one. So num1 became 101. I didn't provide num2, so it got the default, 100. I, of course, also could have said, and I would recommend, num1 equals 101. Just makes everything a lot more clear. Now, when we run it, same thing. Let's go print out 1,000. So default parameters. These do come in very handy, and you'll see them particularly in the framework. So you're going to use a lot of code that was written by Google as part of the Kotlin libraries, and you'll see this pop up pretty regularly. It just makes for a nice, clean way of writing code. In like the old days, we would have done this with function overloading, where we'd have big number, and maybe we would define big number with 2 ints. We might define big number with only 1 int. And then in our code, we would default the second one. This just gives you a way of kind of making it one function that we can override and have multiple ways of calling it. So it's pretty nice. Let's see, what else? Oh, okay. Let's talk about optionals just a little bit. Because they can. So let's say that we also, if either number is 0, let's say, again, I'm just making up some silly logic here, but let's say if num1 was equal to 0 or num2 is equal to 0, return null. So for whatever reason in our application, we needed to find the biggest number. But if either one of the numbers were 0, we just want to return a null. So we can do that. I can just go up here and change this now to int question mark. And now we can return a null value. And so let's go down here and let's say val big number equals bigger number num1. Oh, rather than type that out again, what am I doing? Let's just use this one. So what will happen here? We're going to call big number. It's going to return a number. In this case, it won't return null, right? Because it's going to be 101 and 1,000. So we'll get back 1,000. However, it's not an integer anymore. It's an optional int. So the reason I wanted to talk about that is this is returning an optional is very, 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 very common in functions. And the reason for that is a lot of times you'll call functions that are doing something that could potentially fail. So maybe you're calling a function that's going to make a network call to get the data. Well, that could fail. You could end up with no data back, in which case you don't want to return null. You'll see that later in the course. You could be doing some file reads or file writes or database changes. There's a lot of things that could, things could go on in your program and they could fail. And one way of dealing with that is to return back a null. Pretty common. So when we get the null back, what I wanted to talk about here just a little bit was, how we want to deal with those. And we've talked about them a little bit already, but let's just do a little bit more. So let's do val answer. Okay, so let's say that I've got this big number back and I want to explicitly turn it into a string. And I mentioned earlier that we can convert data types. There's all these conversions built in, for example, toString, toInt, etc. So in this case, we've got an optional int, and I call toString. But when I go to run this right now, I'm going to get an error. So when we get back optionals, one of the things that we can do to change this is we add, and I talked about this already a little bit, we add a question mark here. And so what's going to happen is answer is going to be an optional string, but if it doesn't return anything, if it returns a null, right, it won't ever do this conversion. You'll just get back null. If it does return a value, that returns a variable, an optional string that has a value, then it will convert it into a string, and you'll get the string back. And the reason I wanted to, again, talk about this here is on functions, a lot of times we chain functions. So for example, I could say answer equals bigger number, dot toString, dot toUpperCase. And because each of these could return an optional, I flag them as that. So what will happen here is answers potentially could be null if any of these fail. But also if any of these fails, that's where it stops. So if bigger number has a null, it stops. If bigger number calls toString and for some reason string returned a null, it stops. If string returns a value, then it would run toUpperCase. So these things chain together. So if I run it now, we'll see. Oh, got a typo somewhere. Oh, big number. There we go. Big number, not biggest number, sorry. Lowercase t, sorry. I make a lot of typos when I code. There we go. But just kind of give you an idea of what's going on here and where you see that. And you see these with functions a lot, particularly when you chain them together. You might see this big long line of question marks. Understand what you're dealing with. Understand that this could be null as a response. That's the basic of functions. Not much else to talk about, so we're going to wrap this up here and get into some more complicated concepts like lambdas in the next lecture.